Introduction to union, A union B, that's how you read that expression right there. And intersection, A intersect B, is how you read that expression there. Let's start with some definitions of union and intersection. The union of A and B is the set of elements that belong to either A or B. We write that as A union B. And it's very inclusive, right? If an element appears in either A or B, then it's automatically in the union. We can represent this with a Venn diagram. It looks like this. Okay, so if this is A and this is B, the union is anything that occurs in A or anything that occurs in B, or things that occur in the overlap of A and B. So it's everything. So I'm filling in this entire set of two circles here, right? It's very inclusive. Union is very inclusive. The intersection of A and B is not as inclusive. Okay, A intersects B. It's like an upside down U there. It's the set of elements that belong to both A and B. So when we say both A and B, this is the overlap only. Okay, the overlap only. And if we were to draw a Venn diagram here, A, B, right, it's only where they cross. There's the intersection. Here is just that bit right in the middle. Okay, so it's very exclusive. For something to be in the intersection of A and B, it has to be both in A and B. For it to be in the union of A and B, if it shows up anywhere in A or B, it just has to show up once somewhere, then it's in the union of A and B. Let's bring this down to earth a little bit with an example. Let's define the following sets of numbers. Let's let A be 9, 10, 15, and 16. Okay, B is 15, 16, 20, and 21. C is x such that x is an even integer, so this is the set of all even integers. And D is x such that x is an odd integer, so that's the set of all odd integers. This vertical line here is read as such that. Okay, so given those sets, we can do some examples here. Let's do A intersect B. Okay, so let's see. What do A and B have in common? Well, look here. So we're only looking at the overlap. I'm seeing 15 and 16. Right? That's the only ones they have in common. So the A intersection with B is 15 and 16 only. Let's try A union B. Okay, so A union B is everything that shows up ever in either A or B. So anything that shows up at all in these two sets, we're including in the union. So I'm seeing 9, 10, 15, 16, 20, and 21. Okay, so you can see the intersection is very exclusive, the union is very inclusive. Everyone's welcome in the union, right? Everything's can come right in. Anything that shows up at all comes into the union. Only the overlap goes into the intersection. How about this one? A intersect C. Okay, maybe pause the video and try that one on your own. What is A intersect C? Okay, so C is only the even integers. A is 9, 10, 15, and 16. So we want the overlap of all the evens and then 9, 10, 15, and 16. Well, I'm seeing only 10 and 16. Right? Those are the only evens in A, so it's 10 and 16. Let's try B intersect D. B intersect D, okay, that's going to be everything that's in B that is also an odd integer. It's the overlap between these two sets. Okay, well, B intersect D, so the odd integers are 15 and 21. 15, 21. All right. How about C intersect D? Well, this is x such that x is both an even integer and an odd integer. Well, there are no such numbers. No number can be both even and odd, so we have here the empty set. This kind of introductory set theory it's very much related to logic. And when we think of it that way, A intersection B goes along with and. Okay, and. Because for something to be in the intersection, it has to be in both A and B. And A union B goes along with or. Because something is in the union if it's either in A or B. So logically, we can think of these as an and an or.